So solving this inequality, we just do the exact same thing we did with equations, except if we ever divide or multiply by negatives, we flip the sign. So in this case, we could try to avoid multiplying or dividing by negative. Okay, so if I distribute out here, I end up with that, plus 5 is greater than or equal to 4x minus 9. Okay, so I'm going to combine my like terms here. And I'm going to try to avoid having to divide or multiply both sides by negative by trying to move the x's to the side that's going to give me positive x's. Now I don't have to do this, but this avoids having to flip the sign. So if I subtract 2x here, subtract 2x here, I'm going to add 9 here, add 9 here. So that's my 0 pair. And notice that the x's end up on this side, which is the less than side, instead of the greater than side. If it ended up on the negative on the greater than side, then I'd have to flip it when I divide it. So now I'm going to divide by positive, so I don't need to flip the inequality. It just stays as 6 is greater than x as my solution. Greater than or equal to x. And when I put that on a number line, when I show that on a number line, there's 6, and since it's greater than or equal to, I'm going to fill in that and go on to, x is less than. So 6 is greater than, which means that x is less than. So applying exponent rules here, we can distribute that exponent into the brackets. There's no plus. Remember that exponents and plus and minus are incompatible. They don't work together, so we can't do that when we have pluses and minuses. So we're going to end up with x to the power 16, okay, 4 groups of 4, 4 groups of 3 is 12, times, it's all connected by times, so I can just add up the exponents afterwards. So 3 groups of 2 is 6, 3 groups of 4 is 12y's. So total I am going to end up with, this is all connected by times, there's no pluses in there. So I can just count them all up. So 16 and 6 is 22. 12 and 12 is 24. Okay, so there's my simplified version. Here, I probably want to get rid of those outside brackets. So I'm going to work on 2 to the power 5 is 32. 5 groups of 3 is 15. So I have 15 times on top. I have 17 divides on bottom. So when I work this all out then, I can count up my y's. Well, let's work at the numbers first. So 32 divided by 4 is 8. Okay, that's going to be the numerator. Y squared, y, well that's going to give me 1 extra times on top. X15, Y17, well I have 17, 2 more divide by x. So I'm going to end up with x to the power 2 on the bottom. Now this could be expressed as x to the power negative 2, which means that the negative again implies division, or it means division, but I can just actually write it in the denominator as division as well. Okay, so when we are doing some algebra, when we're combining multiplication with addition, we have to be careful because there's a distribution that needs to be involved. And if we're ever stuck, we always use our area model. Okay, so we can show, well, we're going to have to show algebra tiles anyway, so let's show the algebra tiles first. So we have 2x minus 3, and then we have 1x plus 5. Okay, now I don't really want algebra tiles. We're not going to use algebra tiles a lot. Once we understand the algebra tiles, we're going to simplify it to an area model. But for now, we need to still show the tile. You still need to be able to show the tiles. So these are going to, x times x is going to give me the squares here. I'm going to end up with a negative times positive, and that's going to be length of 1, width of x. So I get negative x here. Here I'm going to get positive x's. Okay, positive times positive. And I'm going to have 10x's here. Okay, and I get 5 times negative 5 ones times negative ones. It's going to give me negative, and it's going to give me 15 ones. Okay, it's a lot of ones in there, but I'm going to draw them all in. And this is why we don't want to use this algebra model after a while, because it gets too tedious to draw all these parts out. Okay, so we'll start using the area model shortly. So here we're going to multiply this out. We get 2x squared first outside. There's my 10x. Okay, so there's my 2x squared times 10x gets my 10x. Inside is going to give me negative 3x. Okay, so there's my negative 3x is here. And then negative 3 times positive 5 gives me my negative 15 ones. And so I end up with 2x squared plus 7x minus 15. Okay. Here we're not going to draw the algebra tiles, we're just going to multiply out and combine like terms. Now we have to be careful because there's 3 things being multiplied here. So I'm going to multiply out the first set of brackets. And I'm going to do the binomial first. So I'm going to end up with 2x squared first outside minus 5x plus 2x minus 5. I'm going to combine my like terms, and then before I distribute that negative 4. I have to be careful, that negative in front affects our distribution. So we get 2x squared minus 3x minus 5, and then we're going to just multiply this out. Okay, so when we multiply out with that negative, be very careful because that negative has to distribute into the brackets. Okay, that's why these signs here change. And the last step is combine the like terms. I end up with negative 8x squared plus 15x plus 26 ones. Okay, so the last thing here, we're going to place these numbers on the number line. We should know our perfect squares. So square root 2 is in between 4 and 2. So square root 2 is going to be right in there. It's going to be about 1.41. Okay, square root 7, that's got to be somewhere between square root of 9 and square root of 4. Okay, so it's got to be between 2 and 3, so we're just going to put it in here. Okay, so this is going to be root 7. We should say that's root 2. Okay, now without a calculator, we can't work out that decimal value. Okay, so maybe I'll just erase that here because we want to be able to place these without a calculator. Square root 29. I have to think of my perfect squares that are bigger and smaller. So bigger perfect square is 36, so it's got to be smaller than 6. The smaller is bigger than 25, square root 25, so it's got to be somewhere in here. Okay, so now I'm just going to put it right in the middle, but really we can just estimate anywhere in there, and that's perfectly fine. We're not being asking you to be accurate here. The square root of 90, well, the bigger perfect square is 100, smaller perfect square is 81, so it's got to be somewhere between 9 squared and 10 squared. So square root 90 is going to be between 9 and 10. So there it is.